Okay, so this is lesson 2.4, which is all about proofs. Now, I usually cover this in two different lessons, but luckily I've already taught you guys proofs before this point. They usually don't come up until now, but I was finding that when I introduce them later and you have all these rules in your head, it's hard to pick out which one. So hopefully you're better at that since you saw them one by one. So we've already kind of talked about these properties of equality. Addition says if you add the same thing to both sides of an equal sign, it's still equal. Subtraction is if you subtract them. Multiplication, division, we've done those. Distributive property just means if you have a number being multiplied by something in parentheses, you can multiply it by each one. And substitution is just the fancy math word for plugging something in. Now, reflexive property is probably new because we don't usually talk about that at the beginning of the year because it's not really needed. What it says is something equals itself, which seems like something silly to say, but there's a time when you have to prove that two triangles are congruent. Let me see if I can, let me just draw like this. So we have two triangles here. And if you know this side's the same as this side and this side is the same as this side, you actually have to be able to prove that this third side is the same in both triangles. And that's reflexive property. You just say it's congruent because it's the same line in both triangles and it would have to be equal to itself. So that's reflexive property. The best way I can tell you to remember it is when you look in the mirror, your face is your face. Your face equals your face. So that's reflexive property because it's very close to reflection. Symmetric property we've done where you can flip it around the equal sign. Now transitive property we have not done, and you won't actually put in a proof, you just need to know the property. It's a lot like chain law. If it says A equals B and B equals C, then you can cut out the middle stuff and you get A equals C. It's also very close to substitution. The difference is this part has to become the first part over here. You have to make this little smiley face. And then you can do that. If it's substitution, it will be like, well, that's not what I want. So substitution would be like if A equals B, and then it might say, and C equals B, then A equals C. So that's not transitive property because what you're doing is you're taking this equation and the fact that C is the same as B and plugging that in there. I know they look very similar, and again, I'm never going to have you write transitive on a proof. The only way it's transitive is if the second one becomes the first one. It's all in how it's written. All right, so addition property of equality is where you can add the same thing to both sides. So if this is true, and then it changes from that to this, then this next one would have to be TU plus 20. Because it added 20 to this side, so we have to add it to this side. Multiplication means you're going to multiply both sides by the same thing. So we have angle 1 equaling angle 2. Then it has 3 times the measure of angle 1, so that would have to be equal to 3 times the measure of angle 2. Substitution is just when you plug something in. So if A equals 20, then 5A equals, I know a lot of people want to say 100, but it's actually 5 times 20. Because substitution is just plugging it in, it's not actually doing the arithmetic. Reflexive property is when something equals itself. So if x is a real number, then x equals x. Symmetric property is just flipping it around. So if AB equals CD, then CD equals AB. Now transitive property is when you have this, the second one become the first one, and you make a little smiley, and then you end up crossing out the middle part. So your conclusion from that would be the measure of angle E equals the measure of angle G. I'd like it if you would pause this and then check your answers once you finish. So reflexive property is just when something equals itself, so that'd be the measure of angle B. Transitive is where the second thing becomes the first thing, so this would have to be GH. And then you can cross out the middle part and say CD equals RS. Addition property of equality, if x equals 3, then 14 plus x equals 14 plus 3. It just added 14 to both sides. You could also do 3 plus 14, doesn't matter. Symmetric property is when you flip it. So if BC equals RL, then RL equals BC. Substitution is just when you plug it in. So if the measure of angle A is 45, then 3 times the measure of angle A is 3 times 45. Again, you don't actually multiply it because that's arithmetic. Multiplication, if you have the measure of angle A is 45, then something times the measure of angle A is 15. Now this throws a lot of people off because it gets smaller. Doesn't make it a negative number, it makes it a fraction. So that would be 1/3. Alright, so I just wanted you to try a few of these and see if you can get what they are. So you have to think about what changes from here to here. So all it did was flip around the equal sign, so that is symmetric property. Sorry. AC equals CA. A lot of people put symmetric on this one, but this is actually reflexive. You're just saying something equals itself. We didn't flip it around the equal sign. There's just one equal sign. That's just the same segment. Alright, so if this was in a proof and you have 2x equals 14, and then your next step says x equals 7, it's basically saying what property takes you from here to here. So all we did was divide both sides by 2. So this was division. Okay, so you have this statement, and from that you get this. So I always have to just look at it and see what changed. So the BC moved from here to this side, and now it's being subtracted. So it's as though we subtracted it from both sides like this, and it canceled out over here. So that is subtraction. This one is multiplication. We just multiplied both sides by 2. So a lot of people struggle with stuff like this. You have to think about what changes from here to here. So we just have AB, and now we have AB minus 4. Here we have 14, and here we have 10. So what happened was we subtracted 4 from both sides. Now you would never actually see that in a proof. It's just trying to get you to recognize the properties. So if x equals 7 and 7 equals y, then x equals y. So because the second one becomes the first one, that is, transitive property. It's like chain law. You take out this middle part, and the first one equals the last one. If x equals 7 and y equals 7, then x equals y. This is very close to the last one, but notice this does not become this. So when that happens, all it's doing is saying that you can plug y in for 7. So that is substitution. Okay, and the other lesson on this is just practicing proofs, because a lot of this unit is covering proofs. So hopefully you have folders, and these are probably all different colors on yours, but these are the rules that you should have so far. You should have 8 of them. So we're just going to go through those. So hopefully you underline segment addition postulate. Oh, sorry, I'm bad at underlining. And then you boxed in this. So if you were to put this on a proof, this is what it would look like on the statement side. The segment addition postulate would be the reason. Now, the only time you use this is if you're saying 2 parts of a segment add together to equal the entire segment. You're literally adding segments. If you're not adding segments, don't put segment addition postulate. Definition of a midpoint is only possible if you have a midpoint. It makes these 2 halves congruent because the midpoint is exactly in the middle. Bisector can be for segments or angles. It usually will tell you it is a bisector. And you're just either setting two sides equal or two angles. So either half the segment equals half the segment or half the angle equals half the angle. Angle addition postulate is like what we use on angles if we don't know anything else about the angle. So you don't know if it's a bisector, you don't know if they're vertical, they're not linear, or complementary, supplementary. You're just adding two small parts of the angle to equal the whole thing. So angle addition postulate would be your reason, and you're just adding two small angles to equal the whole big angle. Complementary is when you're adding two angles to equal 90. Supplementary is when you're adding them to 180. But remember, for supplementary, it has to tell you they are supplementary. If you're basing it on the fact that they make a line, its linear pairs are supplementary. That's where you see a line so you know that two angles on it would add to 180. Then vertical angles are congruent when they're across from each other like that, like 3 and 6 or 4 and 5. They are always congruent. So you're setting them equal. And then anytime you have a polygon, this is the only rule we have about polygons, you're either setting two sides equal or two angles. Now I saw a lot of people try to put this entire thing on a proof. You only want one equal sign in the statements side of a proof. So you would just put which two sides equal each other. So on this one we have an angle. It says in the figure below, ray BD bisects angle ABC. Prove that the measure of angle ABC equals 12. So because it says that there's a bisector, that's a big clue that this is going to be definition of a bisector. Now I'm going to go back and look at my rule for bisectors just so we don't mess it up. When we have a bisector, we have the measure of an angle, 3 letters, equals the measure of an angle, 3 letters. You have to put this measure of the angle part. So the measure of angle ABD equals the measure of angle DBC. Now, before you move on, you need to check to make sure that's how this part is, because when you're filling in the blank, this matters. So is this 8x minus 16 to this angle? And it is. If you have no clue what to do, look at what we've done on the second step and figure out what that is in terms of names and put it up there. Figure out what that is and put it up there. So then it says to subtract. Now we could subtract the 4x. We could subtract the 20. But notice the x is going to end up on this side and the numbers end up on this side. So you've got to be careful. So this looks like they subtracted the 4x to get 4x minus 16 equals 20. And if you did that wrong, you would hopefully see that at the next step you would be doing something wrong. So then from there to there, it looks like they added the 16 to that side, so that was addition. Now look at this. An angle plus an angle equals another angle. Not there, not there. That is two angles added together to equal 180, not another angle. Equal 180 equal 90. There is only one that has an angle plus an angle equals another angle. That is angle addition postulate. Angle addition postulate. Then they plug in these two values, but then it says substitution again. So what can we plug into this? That would be that x is 9. So 8 times 9 minus 16 plus 4 times 9 plus 20 equals the measure of angle ABC. Then we do arithmetic to get 112, but we have one more step, and that's because it's not turned around the correct way. So we've got to flip it, measure of angle ABC equals 112, and that is symmetric property. So your proofs on the test will be very similar to this. So you just have to make sure you focus on what's before it and what's after it, and use your folders because those can be very helpful